I have a straight line and there's two numbers on the line, 2 and 4, and I want to find the number that's in between them. That's easy enough. The number that's in between 2 and 4 is 3. And the way that I actually get that is I can add the two numbers together and I can divide by 2, which gives me an average of the two numbers. So on top I would have a 6, and I'm dividing by 2, and that equals 3. So in order to find the midpoint of 2 points, I find the average of the two x's by adding those together and dividing by 2. I'm putting a comma because this is going to be a point. And then I add the y's together and divide by 2 to find the average of those two. So now I'm going to substitute. X1 is minus 5 plus x2 is 9, and that's going to be divided by 2. And in this point, y1 is going to be 3. That's minus 3, and then y2 is 3 and divided by 2. So when I'm done, I have minus 5 plus 9. So I'm going to get 4 divided by 2, comma. And then minus 3 plus 3 is 0 divided by 2. So these 2 points, so these two coordinates for the points, 4 divided by 2 is 2, and 0 divided by 2 is just 0. So this is the point. So again, we have 2 points here, but this time they're not whole numbers. I'm going to do one with fractions after the one with the decimals. So first thing that I'm going to do is I'm going to add the x's together and divide by 2. And then I'm going to add the y's together and divide by 2. So the two x's are going to be 2.5 plus 7 divided by 2. And the two y's are 5 and 6.5. So this becomes 9.5 divided by 2. And 11.5 divided by 2. So 9 divided by 2 is 4.5 plus a quarter, so it's 4.75, comma. And then 11 divided by 2 is 5.75. So we'll do an example that has fractions in it, and we'll set it up by starting with the formula. And then we'll substitute. So x1 will be 3/4 plus x2 will be 1/8. That whole thing will be divided by 2. And then the y's would be 2/5 plus 1/2, again divided by 2. Now, in order to add these two fractions together, I want to change this one. We use 8 as my common denominator. So if this is times 2, this is times 2. So this would be 6/8 plus 1/8. This would become an 8. That's times 2. So this would be 6/8 plus 1/8 is 7/8 divided by 2. And then over here, when I have a 5 and a 2, they're both prime numbers. I'm going to change them to tens. So this was times 2, so this is times 2. And then over here, this would be times 5 to become a 10, so this is times 5. So then 4/10 and 5/10 is 9/10. So in order to cut a fraction in half, you can either double the denominator or you can cut the numerator in half. So this would become 7/16, comma, and same thing here. I don't want to cut this, and I'd have a decimal in the numerator. So I'll just double the size of the denominator, so I get 9/20. And that one's done. So if I'm given the endpoint and the midpoint, I want to find what the other endpoint is. because this is the midpoint of two unknown. We'll call this x2 and y2. So I want to find x2 and y2 that these two had a midpoint of 9, 8. Well, knowing that, I'm gonna set up the formula. There's a quick way to do it. How far away are these two from each other, the x's? Well, they're 4 spaces apart. So if I add 4 to this, it should be 13. And if I add, these are, this is 5, 7. So the y's are 1 apart. So I add 1 to this. So I should get 13 and 9. Well, since I know that setting up the formula is going to yield this midpoint, I can use that, and we can do a little bit of practice for algebra. I knew that the x's, when I add them together, 5 plus x divided by 2. Well, this entire value, the midpoint that it gave me was 9. So if I multiply both sides by 2 to get rid of this denominator here, I get 5 plus x equals 18. And subtracting 5 from both sides, I get x equals 13. Well, this here is verified, that is 13. So for the second one, I knew that adding the y's together, which was y plus 7, yielded an 8 for the midpoint. This is divided by 2. So if I multiply both sides by 2, I would get y plus 7 equals 16. And then subtract 7 from both sides. And then I get y equals 9. And that confirms this. One final thing that I'd like to talk about before the end of the video is this has a lot of applications in geometry and for proofs. For example, if this was an isosceles triangle and these two sides were equal, this would be an angle bisector, and these two angles up here would be the same. But the other thing is, this over here would be the midpoint between here and here. And then in circles, if I had a diameter and I had a chord that was cutting this at a right angle, these pieces here, these pieces, this one here and this one here would be equal.